Hello everyone, and welcome to your walkthrough for week 5. This is worksheet 3D. This is further examination of exponential growth and decay. We have a fancier model that we're going to use for this one than we used in 3C, but effectively it's doing the same thing. So first off, the formula we're going to use is right here. Once again, we have our starting amount, which is in this case called the principal, and then the ending amount is just called amount on here. We still have the 1 plus, and then the rate is still in there. Now we've added the letter N to a couple spots. So N is the number of times per year that interest is compounded. So sometimes they'll say it's compounded monthly, or sometimes it'll be compounded semi-annually, or something like this. So you'll just put how many times it gets compounded per year. Now that will make a big difference, as you see in a couple of the problems, at your final amount, but that's essentially what the N represents. Okay, and then T is just how much time you're using in years, and I think it'll make a lot more sense as we go through an example. So write this down somewhere. Like I said, this is the fancier formula. The way you know which formula to use is if your question is saying anything about how often it's compounding, this is the formula that you want to use rather than the old one, okay? So first of all, let's look at number 1. So number 1 says we have $5,000 deposited into an account, so that's going to be our principal, that earns 8% interest, which is going to be 0.08 for our rate, compounded twice a year. So the N in this case is going to be 2. So we're going to plug in that 2 at 2 different spots. Okay, so and then it asks you what the balance is at the end of different time frames. So let's do letter A. So letter A, we plug in the $5,000 principal. The 0.08 is my rate. The 2 for compounded twice a year is there in 2 spots. And then since 6 months is half a year, that's what I put next to the 2 in my power. Okay, so if you do all this in a calculator, just be very, very careful about how you plug that in. You should get $5,200, which makes sense. Okay, next one, it says how long is it going to be after a year? So exact same thing as I had in step 1, except now that half is a 1 because it's 1 full year. So that's the only change between the last formula and this formula. And after a full year, you should have $5,408. Letter C, exactly the same as the previous 2, except now it said it's 18 months, which is 1.5 years. So we plug in 1.5 in for T, and that's how we get this one. And it says our ending balance is $5,624.32. Letter D is exactly the same as the previous 3, except now the T is 2 because it says how much money you're gonna have after 2 years. So we plug in a 2 for T. You got $5,849.29. So number 4 says $2,000 is deposited into an account, so that's your principal, that earns an interest rate of 8%. So once again, 0.08. That's going to be compounded 4 times a year. So the first thing they ask is, what's the interest period? So I've never really talked about this with you, but basically an interest period is you take your interest rate divided by how many times you're compounding, and that's what it's going to be. So each compounding period is interest period is going to take that little bit of the percentage, if that makes sense. So I take the 0.08, which is my percentage, divide it by 4 because it's going to happen 4 times a year, and you end up with 0.02 or 2%. So 4 times per the year, you're going to add 2%, or it should be adding 2% to whatever the principal is. Okay, B says, what is the balance at the end of the first period? So period, they're saying is like 4 months. So our amount equals our principal, which is $2,000, times 1 plus the rate, which is 0.08, divided by 4 because we're compounding 4 times a year, to the 4 times a year, so that's the 4, and then the 1/4, that's how long of or how much of the year we're looking at. So 1/4 of the year is 4 months out of 12. So that is what we have. So if you do all that on a calculator, you'll end up with $2,040. Okay. So now let's skip down to number 7. So number 7 is a great question. It says, suppose you go back in time and you go to the year 1776 and they're signing the Declaration of Independence. They're throwing tea in the Boston Harbor. All of these things are happening. It probably smells awful, but you find $1 and you talk to a guy and you say, I want to deposit this and I want to earn 8% interest forever. And the guy says, okay. So you take your time machine, you go to 1976 and you go to collect your money. Well, this is looking at all the different situations in terms of compounding. So compounding means we add the interest once per year. So that's the yearly one. So let's look at that. That's in red. So our amount is going to be our principal of $1 times 1 plus the 8% interest. It's going to be compounded once a year. So that's why there's a 1 on the bottom. And then we have a 1 for the exponent times. And then you jumped forward in time 200 years. So that's how I got the 200. So if it's compounding once per year, you're going to end up with $4,838,949.57. Pretty good for a dollar investment. Let's look at the blue one. So the blue one says semi-annually, which means it happens twice per year. So our $1 principal times the 1 plus 8%, so 0.08, divided by 2 now because it's doing it twice a year. And then 2 is in the exponent with the 200 years. Do all that on a calculator, you end up with $6,506,324.50. So you can see there's a pretty dramatic difference between having it compound once a year and twice a year. That's almost a $2 million difference. So something to think about. Now, last one, what happens if you do it monthly? So this is how credit cards do it. This is how mortgages do it. So let's look at what it would be if it was monthly. So our $1 principal times the 1 plus 0.08 divided by now 12 because it's compounding 12 times in a year. And then 12 is in our exponent times the 200 years again. And this one we end up with $8,426,588.18. So massive difference between that and our yearly number. It's almost double. So if you're ever doing an investment, a really good question to ask them is how often is this going to compound? Because the more it compounds, the more money you get, okay? All right, so that is it for this worksheet. This was 3D, or Unit 3, Worksheet D. The answer key for the rest of them is on Schoology, so if you look at those, you're not sure how I did something, please ask, as well as you can ask me in class when you see me. We have one more worksheet of new stuff in Unit 3, which is 3E, and then F is going to be the review, which is all going to be done for this week. So, like I said, any questions, give me an email, and other than that, have a lovely day.